A solution of higher mathematics for class 10 under the syllabus of Board of Secondary Education Manipur. Solved and recorded by Salam Megasundar Singh, lecturer, Chusan Higher Secondary School in Pan. Chapter 1 Binary Operation. What is binary operation? Let S be a non-empty set and O be a mapping of the Cartesian product S into S to S. S हाइबसे हामदब सेट अमनी O हाइबसिना S into S तगी S तो ओइबा mapping अमनी हाइबदी S to यावबा any two elements to O हाइबा operation से पांथोपदा S to यावबा element दा always हलाई हाइबने. Any two elements of S combined with under the operation O gives an element in S. Then O is called a binary operation on the set S. For example, the operation O defined on set of natural number n by x or y whose value is given by x plus y is a binary operation as x plus y belongs to n. Any two natural numbers की addition asi natural O, therefore x or y c belongs to n O for any x y belongs to n O. Therefore, the operation O defined on n is a binary operation. Similarly, the operation asterisk defined on z by x asterisk y equal to x into y is a binary operation as x into y belongs to z. Any two integers की product C integer oibanina x asterisk y as C belongs to z for any x y belongs to z. Therefore, operation asterisk defined on z is a binary operation. Matang asida aykon nningsingba yai binary operation oidaba case khara lokalari yangsi. X amasung y haiba number natural number ani khat lokasi ahanba case asigi opposite ona toba ama. X minus y asi matam punamakta natural da yaude. Sina karita is subtraction haibase is not binary operation. Binary operation oide. Amuksu hariba case asimakta natural number ani si integer ani divide on si. Ani suba case ki harap integer ani divide on si matam punamakta integer da halakti. Paramasina division haibase is not binary operation. Division haibase binary operation oide. Subtraction su oide. Sigi kona khange subtraction amasung divide haibase binary operation oide. Respective set singa sidani set of natural numbers tani subtraction adu divide set of integers tani hoji khanari base. External binary operation. Let A and S be non-empty sets and F such that A arrow B S to S be a mapping. A amasung S haibasi any two sets ni. Non-empty sets ni F haibasi na Cartesian product A into S tagi S to oiba mapping amani. Haibadi A set yauba element amaga S to yauba element aniga multiplication haiba F haiba operation si pangthokpa matamda always S ta halai haibani. Halaklabadi sigi F hariba then the operation F is called an external binary operation on S over A. A into S na A da talakpanate A into S na S talakpane. Kudam, the multiplication of a vector by a scalar is a binary operation. Karigumba vector amada scalar amana puribasi binary operation oy. Masi external binary operation gi kudamni on the set of vectors over the set of scalars. Let's see. Mafam asida area over number amakhak laukasi area over number amakhak laukhalet loinana vector amakhak su laukhalet vector duna S to yaulasi definition ka chanana salasi haribi scalar asina 2 of scalar asina a hariba vector asida purirabadi amu vector phangi vector dudi S ni mafam asida area element 2 asiga S to yauba vector asiga ani scalar asina vector da purirabadi scalar tarakti vector tar A amadana belongs to S karigumba A taramaga belongs to A haigadabani mafam asida set 2 S puna set of vectors pu khangnare, A na set of scalars pu khangnare. Algebraic structure. A set equipped with one or more binary operations is known as an algebraic structure. Kariguma set amaga binary operation ama nataga amadagi himbaga loinarabati adugumba adubu aikona algebraic structure kawi. If asterisk is a binary operation on the set S, then the pair S comma asterisk is an algebraic structure. S asterisk na S to define over binary operation amo order order pair S comma operation asterisk. This order pair is an algebraic structure. For example, number 1, n plus is an algebraic structure as addition of any two naturals is again a natural number. Natural any two natural order pair n plus have a algebraic structure amani. Associative binary operation. When is a binary operation said to be associative? A binary operation on a set S is said to be associative if X or Y or Z equal to X or Y or Z for every X, Y, Z belongs to S. S the binary operation O asi associative O haigani X or Y की value का result का Z का punjin bagi pol का Y or Z hana combine punjin laba matung da phangku result के S का punjin bagi polo mana rabadi haibadi number ahum si different ways the grouping toraga same result phangba mana ba haibani. For example, the binary operation O defined on N by X or Y equal to X plus Y is associative on N. Natural number tension number C associative property chumbanina X or Y associative belongs to N the halakani for whenever X and Y are any natural numbers. The binary operation asterisk defined on Z by X asterisk Y equal to X into Y is associative on Z. Integer ahum tension number C su grouping in makha ponde. Commutative binary operation. A binary operation O on a set S is said to be commutative if X or Y equal to Y or X for every XY belongs to S. S the defined about binary operation O asi commutative O haigani X or Y की value का Y or S की value का मानरबदी where XY belongs to S ओइगदबनी हाइबदी हाना कोनगी मथंग मनावगी मखा पोंदे हाइबनी associative तना grouping के मखा पोंदे commutative तना मथंग मनाव नत्रगा ahana kongi maka ponde. For example, the binary operation O defined on N by X or Y is equal to X plus Y is commutative on N. Why? Any integers, any natural number any addition se ahana kongi maka ponde X plus Y की value su Y plus S की value su माने. Therefore, X or Y की value X plus Y ni Y or S की value su Y plus X, then is X plus Y. The binary operation asterisk defined on Z by X or Y equal to X into Y is commutative on Z. Any two integers की product से ahana kongi maka ponde. There is, we have learned in previous classes that 2 into 3 which is also 6 and 3 into 2 which is also 6. Therefore, 2 into 3 equal to 3 into 2. In general, X, Y equal to YX. Therefore, product is commutative. In here, addition is commutative, but it fails in the subtraction and division. Distributive binary operation. Let asterisk and O be two binary operations on a set S. Same set of binary operations. Then asterisk is distributive over O if X asterisk Y O Z equal to X asterisk Y O X asterisk Z and Y O Z asterisk X equal to Y O X O Z O X for all X Y Z belongs to S. For example, the binary operation multiplication is distributive over addition on the set R. Let's see. 2 times of 3 plus 4, whose value is equal to what? 2 into 7, that is 14. Also next, 2 into 3 plus 2 into 4, their value is 6 plus I, that is 14. Therefore, these lefts are equal. X times of y plus z equal to xy plus xz, and y plus z times of x equal to yx plus zx, for x, y, z belongs to R. Subsets close under a binary operation. Subsets close under a binary operation. Let O be a binary operation on a set S and I be a subset of S. I haibasi S ki subset amani, O haibasi S to oiba binary operation amani. Then I is said to be close under O if A B belongs to I into I, that is A or B belongs to I. I haibasi close oiba haibani haibadi I ki yawe any two numbers ki operation pangthokpada I there always return taropa haibani. For example, the addition is a binary operation on the set of real numbers. Addition haibasi set of real numbers the binary operation or the set Q, the set of rational numbers, is a subset of R. Q is R is subset, and this Q is closed under addition. Hariba Q as issue close or under addition. But QC set of irrational numbers is a subset of R. Q power C, Q complement haibasi R is subset amani, but Q complement is not closed under addition. Why? Real irrational number anigi sum as irrational tadabaya. Suppose 2 plus root over 3 hariba irrational number siga. Next, plus 2 plus 2 minus of root over 3 siga ani si punsin si. Haibadi 2 plus root over 3 siga 2 minus root over 3 ani si adding tawrabadi 4 times 4 asidi QC the yaudu. Identity element. An algebraic structure SO is said to be with identity element if there exists E belongs to S such that X or E equal to E or X equal to X for every X belongs to S. Algebraic structure amada identity element lay haigani adugumba S da element ama layrabadi X or E ga E or S ka kudingmak X tarabadi for every X belongs to S. For example, number 1, 0 is the additive identity element of algebraic structure Z plus S, X plus 0 equal to 0 plus X equal to X. X belongs to Z. Any integer ga 0 ba tinsunabada any integer type 0 asibu additive tinsunabagi oiba identity element ko in zeta on zeta. 1 is the multiplicative identity element of algebraic structure n dot s. X dot 1 equal to 1 dot x equal to x. X belongs to n. Any natural number amaga 1 ga purinabagi policy any natural number to tie 1 asibu purinabagi multiplicative oiba identity element ko. Theorem. The identity element for an algebraic structure, if it exists, is unique. Karigumba algebraic structure amagi identity element layrabadi amakhtang oigani. Proof. Let SO be an algebraic structure. Suppose E1 and E2 are two distinct identity elements in S. Hariba S hariba set asigi identity element ani E1 amasu E2 haba manadaba ani layhana lawrasi. Since E1 is the identity element, E1 or E2 be equal to E2. Any element in the set S2 ga identity element ga or operation function or the any element makamasi da E2 na khang E2 tagani. And since E2 is the identity element, therefore E1 or E2 equal to E1. Mafam asida E1 asi definition yaw to X any element in S2 ni. E2 have identity the mahak operation function E1 tagani. Now two lefts are equal, therefore rights are equal. Therefore E1 equal to E2. Thus our assumption is wrong. That is E1 does not equal to E2 is suppose. E1 amasu E2 manade haibasi aikoina lawkare, but manadaba anido hojikti manarakle. Aikoina lawsing khibadu lale. Hence the identity element for an algebraic structure, if it exists, is unique. Karigumba algebraic structure amagi identity element lairabadi amakhatang oigani habadu pramanta. Inverse of an element. Inverse of an element. Let S or be an algebraic structure with identity element E and let S be an element of S. S or haibasi algebraic structure amani mahake identity element to lay hanelo simadu E ni X haibasi S ke any element ni. An element Y belongs to S if it exists is said to be an inverse of X if X or Y equal to Y or X equal to E. Karigumba apiba X haibasi inverse haragadi S ta Y have element ama lairagadi Y have element si oigani. Karama matamda X or Y ki value ga Y or S ki value ga makoi ani ki combination sing si managani lone na makoi kudimak identity element E tagadagan. For example, minus X is the additive inverse of X of algebraic structure Z plus S. X plus of minus X to 0 time minus X plus X to 0 time X to any integers. Theorem. If S O is an algebraic structure with identity in which the binary operation O is associative, then the inverse of an element of S if it exists is unique. Identity element leiba algebraic structure amani S O haibasi. O haiba operation asi associative oi S yauba any element amagi inverse lairabadi amakhatong oigani. Mathaki identity ga mane inverse karigumba algebraic structure amagi element amagi inverse lairabadi amakhatong oigani haibani. Let S O be an algebraic structure with identity element E. E sina algebraic structure S O ki identity element ni lawrasi. Suppose Y and Z are different inverses of the same element X belongs to S. S to yauba X have element sigi manadaba element sin hani lawrasi Y amasung Z na. We have to show that Y equal to Z. Then X or Y have a CS inverse orabadi X or Y equal to Y or X equal to E. And Z have a CS inverse orabadi X or Z equal to Z or X equal to E. Now Y E can be written as Y or E because any element with E is any element. Then E have a Z yauba Z comma E have a kana manai matakumari lehawi madu manunda Z yauba na kan amalokatsi Z yauba si the X or aina E gi value si X or Z locale mokoi ahungi grouping ama phanga sigi grouping simak amuksu tana basin si tawudabu Y or X have tana. Now Z have si E or Z hani EVI E have si Y yaw tarandagi Y or X low sira X or Y low sira mafam asidadi Y or X lowrani maramdi Y X Z have si Y X Z have si sigi taken this order tana basin na buhonabada E have si Y O X low something right anisim angang ba iba anisi manare let ani manare that is but O is associative O si associative oibanina. So si angang ba anisi managani whose values are sig B Y lere sig Z lere Y equal Z object Y equal Z avado manadabani hana lowrubani that our assumption is wrong. Hence, the inverse of an element for an algebraic structure if it exists is unique. Karigumba algebraic structure amagi element amagi inverse lairabadi amakhaktang laigani manadaba ani laihani lawrubani hekta manarami adu orabadi manadaba amata laitare haibadi inverse lairabadi amakhaktang oigani.